Alright, welcome back to Geometry, Chapter 8, Section 2. We're doing the Pythagorean Theorem today, which is one of the most famous theorems in math. You probably know what it is. A squared plus b squared equals c squared. What is c? C's the longest side. Whoa! C's the longest side. That means c is the hypotenuse. It's the side opposite the right angle. Doesn't really matter which one's A and which one's B. They are the legs adjacent to the right angle. They're interchangeable. This could be A, this B, or the other way around. But C is the longest side opposite the right angle. Now to find the hypotenuse, if you take the squares of A and B, add them up and you'll get the square of C. Oh, and then square root it. There's nothing to it to find the measure of the longest side. There you go. It's that easy. Quick review of the Pythagorean Theorem. And how does that work when you are looking for something other than C? Well, if you know the lengths of A and C, subtract their squares and you'll get the square of B. Oh, and then square root it. There's nothing to it, even if you know the longest side. So there you go. Quick review of the Pythagorean Theorem, whether you know the hypotenuse or whether you're looking for the hypotenuse, which is C, the longest side. So, now, a couple of things. Pythagorean Triple, you might have heard that term. That is where every number is a whole number, like 3, 4, 5. You might be familiar with that one, but there are others. Now, you can take a multiple of 3, 4, and 5. So if you multiply each one of these by 2, you get a 6, 8, and 10. That's also Pythagorean Triple. Okay. There are other Pythagorean triples, like 5, 12, 13. 8, 15, 17, 7, 24, 25. Now, at least be familiar with this and all its multiples, and I would say at least this one. If you want to learn these next couple ones, they might come in useful at some point too. So, how to use the Pythagorean Triple to find x. Now, we'll always check to see, is there a 3, 4, 5? Or is there maybe a 5, 12, 13? So, there's obviously not a 5, 12, 13. Because this is 12, this would have to be 13. So maybe there's a 3, 4, 5. So let's see whether these could be multiples of 3, 4, and 5. 5 would have to be the longest side, which is the hypotenuse opposite the right angle. So we check, are these multiples of 3, 4, and 5? Well, 12 is a multiple of 4. 4 times 3 gives us 12. 5 times 3 gives us 15. So, since we know that's a multiple of 3, this would be 3 times 3, which would give us 9 for that side. That's how we can use a Pythagorean triple really quickly without even having to square anything or square root it. Then the converse Pythagorean theorem tells us that if c squared is the sum of a squared and b squared, then it is a right triangle. On the other hand, if c squared does not equal a squared plus b squared, then it is not a right triangle. Now, we can find out even more than that if we know that c squared, if I take the hypotenuse, that the longest side, well, it's not the hypotenuse, but the longest side, and square it, if that's less than the other two sides squared, if that's shorter than the other two sides squared, the squares of the other two, then it is an acute triangle. If c squared is less than. Okay? And on the flip side, if c squared is greater than the sum of the other two squares, then it is obtuse. So, we want to look at these numbers and check to see, first off, can these be the sides of a triangle? If they can be the sides of a triangle, is it acute, right, or obtuse? Well, first off, in order for it to be a triangle, if you look at a triangle, these sides together, A and B, can't be shorter together than the side C. So A plus B has to be more than C. Okay, if they add exactly to C, then that's not a triangle anymore. So they have to be a little bit longer than C itself when we add them together. Okay, and so let's check to see. 7 plus 14, if we add those two up, that's greater than 16, so that's good. Now let's check the other sides. 14 plus 16 is greater than 7, and 7 plus 16 is greater than 14. Okay, so that works. So we can form a triangle with these sides. Now, next, we want to determine, is it acute, right, or obtuse? Well, if this was a right triangle, we would take the longest side, that is C. Okay, so we'll put this in for C, and then see, do the squares of the two shorter side equal the square of the longer side? 7 squared plus 14 squared, 49 plus 196. Does that equal 256? It does not. These two sides together are less than C squared, which means C squared is greater than, if we flip that around, this was C squared, okay, and this was A squared plus B squared. So C squared is greater, so the longest side is, the square of the longest side is greater than the sum of the square of the two shorter sides, which means this is an obtuse triangle. So we'll check this one. Same deal, same spiel. 9 plus 14 is greater than 41. 41 plus 40 is greater than 9. And 9 plus 41 is greater than 40. So we have a triangle. And we'll check to see, is this acute, right, or obtuse? 9 squared plus 40 squared gives me 81 plus 1,600. And as you see, that is equal. Since these two are equal, we have a right triangle. There you have it, ladies and gentlemen. That's about all the fun we're going to have today. And I will see you tomorrow.